write it like this just to make it really easy. So F0 equals F of Q0. And then we're going to have F1 equals F of K times Q0. Right? Which we could if we wanted to call that F of Q1. And as in terms of our unwrapping, we're going to implicit in this F1, this is F1, or F0 I mean, and then this is F1. What's the relationship between G and F here? Like if I wanted to follow that pattern, I would maybe logically say that, let me call that G0. I'll say G0 equals F1. G0 equals F1 equals, in terms of this, what's that equal to? Somebody want to help me? What's that in terms of? G0 equals F1 equals like right.
Why is G0 not equal to F0? Or is it like, because F0 is F of Q0, so then shouldn't G0 be G of F0?
Well, I guess G0 is whatever we want to define it as. Like G0 is a new variable that I'm just throwing down here, so we can define it to be whatever we want it to be. One nice logical rationale is to make G be one iteration back behind F. So if there's F0, F1, F2, F3, and so on, let G be one step backwards. So that we have G0 equals F1 equals the square root of F0 squared plus 1. Like that's kind of the numbers work out that way. It doesn't really matter, you could call it whatever you want, I suppose, but if you just let G0 equal one step back, then that's F0 squared. Now let me say G1 equals F2 equals the square root of F1 squared plus 1, let's say. Now help me get that in terms of F0. Like what is F2? You don't even really need to use the G's. I'm just putting them there because it makes it sort of look like this here.
F2 in terms of F0?
Yeah. Like I can just take these off of there too. If it might even be less confusing if I just...
Can you not just say F0 squared plus 2?
Yes. So give me that. Beautiful. Now, let's take F3, and again, I'm just coming up the same as when you're doing the photocell experiment. You go over, you come up, you come around, up, over, and around, and you're just repeating this operation here. And I'm just unwrapping this. So F3 is the next one. And that is equal to square root of F2 squared plus 1, which equals, what's that in terms of, unwrap that right back to the beginning. Is what?
Same one, but instead of plus 2, plus 3.
Yes. So that's the square root of F0 squared plus 3. Now, let's take the nth term. Let's take the nth term, F sub n equals the square root of F sub n minus 1 squared plus 1, which equals,
Is it this? Or not?
yes. So now, if we want to try to, the goal of all of this is to unwrap this. You can see how we're going around these series of iterations. We come up, we go over, around, up, over, around, and you can see we're just doing this to the nth step. Now the comparagraph theory tells us what to do next. What do we do next? Like, how do we actually solve this comparametric equation? F of n F of n is what did you say? F of n is
like k to the power of n and q.
K to the power of n.
Or is
Yeah.
it k to the power of n?
Yeah. K, but we don't have k to the power of n. We've just got n. So what do we do there? How do we solve that? Like, what's the goal? What are we trying to do? We want f as a function of what? I mean, this is just the general term f, right? Fn is just stands for f, right? F equals f sub n. Remember, we had like F1, F2, F3. In the general case, F sub n is just F. And what is it that we want when we solve a comparametric equation? We've got G as a function of F, and what do we want to end up with?
F as a function of q.
Yes, correct. We want F as a function of Q. So we want to get F as a function of Q, given G as a function of F. Right now we've got f as a function of n rather than f as a function of q, because f naught squared is just a constant plus this variable n. The only variable here is n. So f is some function of n, but we want f to be a function of q. So what do we do? This is a graph here. Think about graph theory.
Are we considering that here as well? Is that the case?
Well, this is true, right?
Yeah.
So you can use it.
So we just substitute n into the. So we have f1 squared plus log f.
Exactly. This statement here is true. Remember that the graph, by definition, this is the fundamental truth that we seek here. One of the fundamental truths. So obviously this is the same n that we're talking about here. Right? It's the very same n. It's the comparametric step of comparametrics, you see, and this comes right from graph theory, quantigraph theory. So now what happens? Now take me down that rabbit hole. This is the next little rabbit hole there. Now what I'm going to do is I'll rub off some stuff in the middle here to make some room. Okay, so now
You want me to write this here?
yeah. Beautiful. So now that's f is the square root of f0 squared plus log k of q over q0. Now, where's the variable here? What's a constant and what's a variable? Can I simplify that any further?
K is a constant.
K is a constant. What else is a constant?
Q naught, F naught.
Q naught and F naught. So what I really probably want to do is try to get all the constants together. Like this is a constant, so let me circle the constants here. In, see another color here. I'll circle all the things that are constant. So how can I kind of group some of the constants together so that they're not sprawled all over the place?
Can you expand the logarithm?
Yes, that would be a really good idea.
So do something.
Exactly, exactly. So now I'll write that just a little tighter,
Yeah, sorry.
which is okay, yeah.
Would you want to also do like divided by log k, or is that not cool?
Yeah, we can do it that way. Like we could certainly write it like this. We could write it as, let's say we could write it like this, f0 squared plus log sub k of q minus log, or we could even say, you could divide it out too if you want. You can say log of q minus log of q0 over log of k if you want. And the important thing to realize here is that this is the variable, and variables in red, and in purple I have the constant. So let's see Purple represents the constant. Let C equal f0 squared plus log k of q0, or minus, actually minus log k of q0. Let C equal this, right? Okay, so now, then that whole thing, now f equals the square root of C plus log, actually I'll write it the other way, I'll put the C at the end, it doesn't make any difference really, but I'll say log k of q plus C. There's my solution to the comparametric equation. I've just very wonderfully solved a comparametric, or we've all together, because we've got a strong sense of we here, we've all together solved a comparametric equation. So this is a solution to that. Now let us prove or show that this is a solution to that, just to confirm that we're right here. So what we're saying is that this comparametric equation admits the following solution. F equals the square root of log k of q plus c. Sometimes I'll write this as just F equals the square root of big Q plus c, following the way I write in the textbook. Sometimes I use big Q to represent log k of little q. The base k logarithm of little q is sometimes written as big Q. So it's a very simple solution to this comparametric equation, and then we want to just verify, in fact, that it is a solution. It's a very wonderfully simple solution. How do we verify that it is a solution? Well, what we could do is we could write this. I'll write this back over here again. So F, and I'll just write this up here again, equals the square root. I'll just unsolve it, right? You guys know how to unsolve a comparametric equation, right? Log k of q plus some constant c. And then over here on this side, I'll just this off here. Over here on this side, I've got g. What's g by definition? If this is f, then what's g? Yes. Square root of log k of kq plus c. Right? Now I can square both sides. On both sides. I can square both sides of this equation and square both sides of that equation, right? A simple problem. So now I've got f squared equals log k of q plus c. And over here, I've got g squared equals log k of q plus c. Log k of kq plus c. Now, let's go what should I do next to unsolve this comparametric equation? Because it's a lot easier to unsolve comparametric equations than it is to solve them, obviously.
Like subbing, like f squared minus log kq is c, and sub that to c.
Yeah, you can do that. A quick thing to do is just to say f squared minus c equals log k of q, and then to go over here, g squared minus c equals log k of kq plus c, which equals log k of k plus log k of q plus c. What's log k of k?
Why is there still a C? On the right.
Oh no, you're right. The c's gone. You're right. The c's not here anymore. C's over here. Yeah, you're right. That's just log k of k plus log k of q. What's log k of k? 1. That's just equals to log k of q plus 1. Now we bring these two together, right? It's over here, it's over here. Relate them and get rid of q. That's the definition of a comparametric equation, is you got to get rid of q to unsolve the comparametric equation, right?
F squared is G squared minus 1.
Yeah. So recognize you've got this here, and recognize you've got this here. And so now we've got f squared minus c equals g squared minus c, right? Well, the simplest thing to do is just, actually the way to make it most obvious, I think, is just to come over here like this, and then say okay. Actually, I'll come around to this side. I'm gonna bring it around to this side. Now we're gonna say that g squared minus c equals, this is just f squared minus c, right? Plus 1. Got it? And then g squared equals f squared minus c plus 1. We've now got g squared is equal to f squared plus 1. Therefore, g equals plus or minus square root of f squared plus 1, which is the same thing that we started with. Obviously the negative side isn't there, but it's the positive side of that is the same thing we started with. So now we've just solved the comparametric equation and proven or shown that the solution is correct. And I think that helps. So let's celebrate with a slice of watermelon. This is summertime, and we've solved, together we've solved a comparametric equation. I'll wash my hands, get the chalk dust off my hands. All right. I'll just clean off the knife by slicing into the Okay, who wants a slice?
Thank you.
yes.
It tastes really good.
Yeah.
Very summery. Thank you. Imagine this like
We had a great swim yesterday. Hey, you want to get in a circle? You want to do a circle picture? All right, if we're all in a circle, a summertime circle. Now I'll get my, all right, 1, 2, 3.
I kind of want to feed the pigeons.
Mm.
Oh no, I mean, they eat garbage. I really need to know that.
Mm.
It's good. I was wondering if you, I know you got my email about my gifts from Lab 5.
Yeah, I saw it.
Yes.
It looks good.
Cool. I was wondering if you, yeah, so I know you said to see if I could stay still. I was like pretty much in the same position the whole time, so.
Oh, okay. The wave's dancing around a little bit,
Yeah.
but it's pretty good though. It's quite a bit better. You can see it, you know.
Yeah.
At least the whole room's not dancing around, and that's a big improvement.
I guess I was just wondering what
Another
my
hit.
grade is. Oh, thank you. My grade is for the lab, like, so I can calculate what I need on the final.
I'll take a look.
Okay. Thank you. Great.
Yeah, I just saw it as I was running out the door.
Okay.
Anyone want a second hit?
Thank you. I'm a little cold, but otherwise it's very tasty.
When are you planning to go to China?
Pretty soon, I think. That's fine. Yeah, I think I'm going to go pretty soon.
I'm going to go there on the 9th. Stay there for a while too.
9th of May?
Yeah.
Oh, cool.
Shanghai first, and
Oh, wow.
there's no other flight.
So what are you doing in Shanghai?
Oh, it's a transit.
To where?
Transit to Tianjin, my hometown. Well, I'll probably stay there for a while. Visit some friends.
Oh. I might be back by then,
Oh.
unless I stay longer.
Oh my gosh.
Do you think I can, if I ever go to Shenzhen, I can come to your lab sometime and check it out?
Yeah.
Okay.